Good morning, ladies and gentlemen. I'm your host, Annalise Garrison. I'm an NCLEX tutor, and I've been tutoring since 1997. And today, we're going to learn how to do IV calculations. So let's jump right into it. Figuring out dosage calculations is really quite simple. It's easier than you might think. There's only three things you have to do. The first thing you have to do is change the hours to minutes. Once you find the minutes and figure out the minutes, set it aside. Then you look at the tubing and you figure out the drops by the order of drops and the tubing size. And we'll go over that in a minute. And then you set that aside. So you find the drops, you find the minutes. Once you've done that, you divide the drops by the minutes, and that will give you your drops per minute. And there you have it. Now let's get into it and try a couple of these. So let's look at the first question. Calculate the flow rate for manually regulating IV using the drops per minute. Ordered: 1,500 milliliters, 0.45% normal saline over 12 hours. The tubing is 15 drops per milliliter. Write the number only of the drops per minute. So the first thing you want to do is change the hours to minutes. So you go 12 hours. 12 times 60 is 720 minutes. Right? So put that aside. The second thing you want to do is find the number of drops. Now the doctor ordered 1,500 milliliters in 12 hours. So we take 1,500 equals X drops, because I don't know that, right? And so, but we do know that 15 drops is 1 milliliter. So this is the way I figure it out. I put 15 drops equals 1 milliliter. See right here, 15 drops equals 1 milliliter, and X drops equals 1,500 milliliters. That's what the doctor ordered, 1,500 milliliters. We're looking for drops. Now it's important that you keep the drops in one column and the milliliters in another column. Do not mix the two. Put drops to the left and milliliters to the right, or milliliters to the left and drops to the right, however you want to figure it out. Just keep drops with drops and milliliters with milliliters. And it also doesn't matter if you write it X drops is 1,500 milliliters or 15 drops is 1 milliliter. It doesn't matter which way you write it. Because if you times diagonally and divide by the X, times diagonally, 15 times 1,500 or 1,500 times 15, either way you write it, 1,500 milliliters times 15 drops divided by 1. So times diagonally and divide by the X, and you come up with 22,500 drops. So far we have 720 minutes, and we have 22,500 drops. The last thing we want to do is divide the drops by minutes. So 22,500 drops divided by 720 gives us a 31.25 drops per minute. How would we write that? We would write our final answer as being 31 drops per minute, because the question said write the number only of the drops per minute. Now, if it was 31.5, then we would have rounded it up to 32. But it was 31.25. So the whole number is 31 drops per minute. Our final answer. All right, let's try another one. Let's try the second question. Calculate the flow rate for manually regulated IV using the drops per minute. Ordered: 40 milliequivalents of potassium chloride and 100 milliliters of normal saline over 40 minutes. The tubing is 20 drops per milliliter. Write the number only of the drops per minute. So first, change the hours to minutes. In this case, we don't have to change the hours to minutes because it's already in minutes, 40 minutes. So put 40 minutes and set it aside. Second, find the number of drops. We know that 20 drops is 1 milliliter. So 100 milliliters is how many drops? So we would write this like this. 20 drops is 1 milliliter. So X drops is 100 milliliters. That's what the doctor ordered, 100 milliliters. And X, we're looking for the drop, so that gives us an X. So if we set it up like I have on the left, or whether you set it up like you have on the right, it doesn't matter. Because we times diagonally and divide by the X. We times diagonally 20 drops times 100. So, or 100 milliliters times 20 drops. It doesn't matter how you calculate it as long as you set it up like this. The key here is to keep drops with drops and milliliters with milliliters. Don't mix the two. Set it up exactly like this. And so we have 100 milliliters times 20 drops. And then we also divide diagonally. So you divide by the X. So divided by 1. So 100 times 20 divided by 1 is 2,000 drops. So we have 2,000 drops and we have 40 minutes. So all we have to do now is take the 2,000, divide that by 40 minutes. 2,000 drops divided by 40 minutes is 50 drops per minute. So our final answer is 50 drops per minute. Very good. Okay, you're doing great. Now let's try another one. Calculate the flow rate for a manually regulated IV using the drops per minute. The order is 250 milliliters in D5W over 3 hours. The tubing is 10 drops per milliliter. Write the number only of the drops per minute. All right, so without looking, what do we want to do first? We want to change the hours to minutes. So this is the way I do it. 1 hour is 60 minutes. See, so keep the hours with the hours and the minutes with the minutes. So 1 hour equals 60 minutes. 3 hours equals X minutes. This is how I do all my conversions. It's really easy. So if we times diagonally and divide by the X, 3 times 60 divided by 1 equals 180 minutes. Okay, so we figured out the minutes. Now put that aside. Second, you want to find the number of drops. So write down what the tubing is and what the doctor ordered. Now let's look again. The doctor ordered 250 milliliters. We want to find out how many drops are in that we have to give for 250 milliliters. How many drops are in 250 milliliters? So if 10 drops is 1 milliliter, then 250 milliliter is how many drops? So you write it like this. 10 drops equals 1 milliliter. Again, keep drops with drops in the same column and milliliters with milliliters in the same column. So 10 drops equals 1 milliliter. We know that. And we know that he ordered 250 milliliters, and we don't know how many drops that is. So we times diagonally and divide by the X. We times diagonally. 10 times 250, diagonal, right? This is diagonal here. Divided by the 1. So 10 drops times 250 divided by 1 is 2,500 drops. So we have 2,500 drops divided by 180. See? 2,500 drops divided by 180 gives us 13.8 drops per minute. Now, we cannot give 0.8 of a drop, so we have to round it. In this case, we have to round it up. So our final answer is 14 drops per minute. Very, very good. All right, let's try one more. Calculate the flow rate for a manually regulated IV using the drops per minute. Ordered 1,000 ml normal saline over 24 hours. The tubing is 20 drops per 2 milliliter. Write the drops given per minute. Now in real life, the tubing is never going to be 20 drops for 2 milliliters. It's never going to be 2 milliliters. It's always going to be either 10 drops per milliliter, 15 drops per milliliter, or 20 drops per milliliter, not 2 milliliter. I wrote 2 milliliter here to prove a point to you. Alright, so by now you should know, what do you do first? You change 24 hours to minutes. So let's do that. 24 times 60 is 1,440. Second thing we want to do is we want to take the doctor's order, which is 1,000 milliliters, and we want to do 20 drops is 2 milliliters. So let's write it, and this is the way we write it. 20 drops is 2 milliliters, that's the tubing. The doctor's order is 1,000 milliliters, and we're looking for drops, so that's our X factor. Okay? Now we want to times diagonally and divide by the X. So we want to write it like this. 20 drops times 1,000 drops is 2,000 drops, right? But we have to divide by 2. So 20 drops times 1,000 drops is 20,000 drops. Divided by 2. So it would be written like this. 20 drops times 1,000 milliliters divided by 2 milliliters is 10,000 drops. Right? 10,000. Let's put a drops here. GTTS. So you take the drops divided by the minutes, and we get 10,000 drops divided by 1,440 minutes equals 6.94 drops. Now there's no way you could give 0.94 of a drop. So since that next number after the decimal point is a 9, we want to round up. Okay? If it's 4 or lower, you want to round down. So if this said 6.44, we would give 6 drops. But this says 6.94 drops, so you want to round it up to 7. So our final answer is 7 drops per minute.